Okay, hello everybody. Welcome back to this new stream for the OpenHT project. So today we are gonna try to, if possible, finish routing the power part, mainly around the FPGA, which is the most complex part, and then we'll go down to the transceiver. And yeah, well, we'll see what we can do today. Maybe at first, is everything okay on the stream? Do you hear me correctly? Is the display correct too? Well, I see nobody is complaining, so I guess it's just good this way. Okay, so we already have KiCad opened in front of us. Last time we mainly did low audio. Okay. Yeah, I tried to get the mic closer to me, so audio shouldn't be louder. I can try to improve that. Okay, is this better, or should I crank it up a bit more? Yeah, okay. Okay, let's like this. So just, yeah, okay. I'm gonna get going. I can't crank it up more, so that's gonna be it. All right. So yeah, last time we mainly did all this, so all those vias, the plane on the third layer. And we started also all the vias around the FPGA, and we routed the VCC rail, let's say, which is 1.0 volt. Now we will have to route the 1.8 volt rail, which is coming from here. So yeah, we are gonna have to find a way to bring it around the FPGA. What I was thinking about last time was maybe we could try to create a ring around the FPGA here, but this might get in our way. So let's see what we could do to improve that. So maybe we would like to shorten a bit this. Maybe we can. Oh yeah, I think I have an idea. Maybe we can just move that on the side, this like this. And then we can drag this like that. And this, maybe we can even rotate all this. Like that. Yeah, that would be nice. Yeah, okay. Like this. And so we would have the 1.8 volts going down and then going below this, and then we could bring it around the FPGA, and that would be good. The thing is, we still have to cross this if we want to go So how would we do that? Okay, let's first remove this old part. That one can be moved. Like this. And then have something going out, which is 0.3 millimeter, I guess. That's what we use that. Or maybe 1 volt is maybe the most sensitive part of the power supply for the FPGA. This needs to be low noise, or low. It's tight requirements. We can't have too much voltage drop, but this shouldn't be an issue because it's only a few millimeters or centimeters long. Yeah, let's try. So maybe we can. I wonder. Can we bring this maybe on the bottom layer? And then bring it to the third layer right here. Like that. So we would need ground vias at least here. Violate ERC. How? This needs to be ground. So that we have a return path. So yeah, the return path for this, I don't know how it's gonna be, but yeah, it needs to, they're probably gonna be ground around here on the third and fourth layer, so we need to make sure that it can cross the boundary between the layers, and so this can go this way, so we have room for a via here too. All right. And so now okay, we are gonna get the power supply on the third layer, laying out plane. So it's gonna be 1.8, second layer. Hey, why didn't, like that. Hey, it's not working. 1v8. Okay. Oh, weird. Yeah, if you can get the phase modulator to work, it would be nice. Now that the FPGA is alive again. Did you know in the end what was the problem and why the FPGA was kind of dead for a moment? Ah, Windows, yeah. If you doubt, always blame Windows. It's always gonna cause some trouble anyway, so yeah. Okay, so where do we need our 1.8 volt rail? Ah, the radio, okay. That's unexpected, but yeah, why not? Okay. Let me maybe just check something. Are all the messages? I don't think all the messages are being displayed in the chat, which is weird. Do I need to modify something maybe? Yeah, when you have an error message, you are always the only one having this problem. Okay, so your messages are appearing in the YouTube chat, they are appearing on Discord, but not on the stream, I guess. Are they? No, they are not. Gonna try to see if I can try to fix that. Yeah, you are using the YouTube chat. I saw that, but it should appear on my screen and just right here. So I don't know why it's not. I'm just gonna try to see if I can sort things out quickly. I don't even know where the chat settings are. It's yeah, it's Casey who manages this, Steve. I don't know how he did that. Well, okay. Anyway, people are gonna have the YouTube chat on the side of the video, so it's not a big deal. The Discord messages are appearing, which is what we need. All right, so where do we need the 1.8 volts for? We need it for VCC aux, and also I think we need it somewhere around for the ADC. I don't know the name of it. It was a weird name. Like, yeah, this one. Okay, this one is 1.8 volts too, but they need to be with some ferrite beads to clean it. So yeah, okay. Okay. Like so. Ah, no. And then add a new corner. Oh, yeah, no, I'm gonna go this way. New corner. Where is it? Okay, like that. Oh yeah, maybe we just will go down like this and then use the ferrite beads right here. Yeah, so the problem on the chat is that the messages coming from the YouTube chat do not display in the restream chat. I don't know. Yeah, okay. Incoming PM. Gonna wait for it. In the meantime, we are gonna need our ferrite beads, which were placed around here. So that one and yeah, okay, those two are the one we need. So let's grab them. Did I need to modify the chat and I didn't do it? I don't even know where the settings for the chat are. Okay. I don't need to pause the stream, Steve. I think it should be okay. So this one then. This. and then okay, just can you please write something in the chat so that I can check if it's correct? Ding dong. This one was coming from Discord, right? And yep. Ding dong. Yeah, perfect. Okay, good. Nice. Chat is working, and thank you, Steve, for your time. Much appreciated. So yeah, we can keep going with the layout then. Honk. I don't have my honk t-shirt. I could have. I love honk. Anyway. We need vias. Let's place 1, 2, 3, 4. This one is not in the correct way. Okay. And so, yeah, that needs to be on the 1v8 net, like this. And then we can just, no, not like this. We can use 0.3 millimeters. Okay, like this. That one will just go right there. Okay, like that. And so, yeah, we have the 1v8. So those, if I remember correctly, don't need to be placed if we don't use the analog to digital converter, and the 17,000 elements version of the FPGA doesn't even have the ADC, so it's in that version it's useless to fit them. I think we'll figure that out later on, maybe. Right, and then VCC aux, that I think we can just or maybe could we, so do we need it, oh, I'm lost on my schematic. We don't really need 1v8 around on the top, so we just need a U, a plane in a U shape. Amazing, I like that. And that maybe we can actually bring it around here. Yeah, I think we'll do that. Oh. I'm trying to think if there is one way which is better than the other. I can't really convince myself. Yeah, okay, we only need it from here. Yeah, okay, let's keep it this way, it's good. Then we need to create a second plane. No, sorry, I'm not gonna bother matching the length of the planes. What would wiggles look like in a power plane? That would be fun, I guess. Okay, so this is VCC aux. Ah, shit. I don't like the way they manage the plane creation. It's I prefer when you have to click for the first corner to be placed. Okay, let's just create a shape and then okay, and the freeze from the GPU are still driving me crazy from time to time. Create corner. Great. So like this. Then from here we need to go basically this way, so that we don't want to go in the vias already placed for VCC. So like this. And then create corner. So like, okay, up to here. Like this, and maybe we can yes, this via should rather be here, and then this one can move up a bit. This can be merged. Like that. Ooh! What the heck was that? Ah. Okay, this is better. Okay. All right. This can even go this, and maybe I'm gonna use a wider track for that. 0.2, it's better. We don't, yeah, we could even use longer tracks. Can even do that actually. And same goes for, I guess, here. and here and here. Thick power tracks are always better. This can be 0.3. Yeah, and then we can drag a track, thick track there, this way, and then, okay, that's starting to look nice. Maybe we can even try to fit the ground via here and move that on the side a bit. Okay, like this, and yeah, same goes on for here. I would prefer if we could... oh, we have a VCC via... Yeah, but we can't, no, we don't need it, we have it here, and it's gonna be the only one we need. Okay, I know, I'm gonna... So always thinking about, so we don't see it, but those two are gonna create an opening in the ground plane on the layer, on layer 2, and we don't want this opening to be too large, so taking care of positioning them correctly, like this. And so if we get this one a bit further away from that one, we have more room to place the ground vias too, and this stops being an issue. At least it should stop being an issue. Can we maybe just display quickly the... those are too close. Well, I can just actually do that. Then this can go right here, this can go up here, this can go up here, like that, like that, and then everybody should be happy. No, this one is still not okay. But then this one is not okay. Okay, good. That should be good enough. Okay. Maybe we can also try to can we try to use wider tracks, or would it get in our way? Ah. It seems to be working. Great. Okay. Well, maybe let's find Indians. Let's pick 1, 2, 5. And then I can get those two closer. No, I can't even. Ah. Well, anyway. And this one. Nice. Okay, so yeah, maybe I'm gonna try getting this one this way, so it's okay. Great. So we just have to put some vias here to connect this to the plane below, and then yeah, we should be pretty much done for the VCC aux plane. Gonna drag that down a bit. I still have to connect a few things here and there, it seems. So this one isn't connected yet. Or yeah, maybe we can do that. Create corner, and one more. And drag that this way. Okay. And so we can have VCC aux vias right this way, 0.3 millimeter width, and need to drag it down one more thick like this. No, like this. Great. Okay. Like this, okay. Yeah, so if the holes are connected, it's not bad, like, yeah, your board is not gonna have any real problem, but it's just so we can quickly go in very technical things if we go down this rabbit hole. But basically, this creates an opening in the green plane. The green plane is the ground signal, and the ground signal, you really want it to be as smooth and continuous and homogeneous as possible, because it's what you are gonna call the real ground. Also, when you talk about a signal which goes like power or signal which goes from one point to the other, you usually only think about the signal itself, but you also need a return path for the mirror part of the signal if you want. So everything that travels from left to right, there is a counterpart that's gonna travel from right to left. And this is gonna travel usually through the ground. And that's why you need to have a good homogeneous ground plane and avoid openings. Because if you have a high frequency signal traveling to ground which have to go around an opening, then the opening is gonna behave like an antenna actually. It's the opposite. So when you usually have an antenna, you have a conductor which is radiating. But you can also do a slit antenna, which is basically a plane in which you are putting a signal, and then you create an opening in the plane, and this opening is gonna radiate like an antenna. And so basically it's just me being finicky and trying to avoid having slit antennas in the ground plane. But I have to admit that it's me being finicky. It's not like, yeah, if you don't do it, your board is not gonna have problems and so on. It's just, yeah, trying to do it as good as possible from the first try. It's gonna help basically with all the EMC consideration, so electromagnetic compatibility, and yeah, thinking about what we are doing, we are basically doing a radio, and then you are gonna have radio signals radiated around your circuit, and you also want to avoid your circuit being a perturbation to itself. So if you feed if the radiations from the radio itself create perturbations on the power signals and maybe on the FPGA and so on, it can corrupt the way the FPGA works if it's too powerful, and then it's gonna be a problem because your circuit is its own enemy, and that you really want to avoid. Ah, you're welcome. Okay, I'm starting to be quite happy with what's going on here. Yeah, this one, yeah, we can basically rotate it so that we can have so those blue signals, they need to be, okay, they will need to move. Light green. The light green area, if I understand, it's this big thing. It's basically the ground plane on the second layer. I usually mask it because it's so large that it's starting to be annoying, and you can't read properly the circuit you're working on. But yeah, you can mask it if you want. It's the ground on the second layer. So if you look at the stack up of the board, you have two layers, first, second, third, and fourth layer. The first layer is the red one. It's the one where we place all our components. Second layer is the grounds. Third layer, it's the orange one. It's the one for the power signals usually. And the fourth one, you also put signals and components if needed. In our case, we only have the buttons on the bottom layer, which we are gonna have to decide. So these shouldn't be mounted, I guess, by the manufacturer of the board. Otherwise, we are gonna have to pay extra for 2 layers assembly with only 2 buttons. So yeah, we'll have to see for that. With the marks around the perimeter. Not sure I understand what you are. Yeah, if you think of this one, it's not yellow. So the bars around the perimeter is just to say that there is a plane, and there is the limitations of the plane. It's no yellow. Oh, this one. Okay. This is so it's on the third layer. It's the ground power signal, and it's the 1V8, so VCC auxiliary, which is one of the power rails that the FPGA needs. And so you have the 1V8 rail here, which goes down from the, so yeah, we can even drag that up. Yeah, we will need to add again corners right here and there, and then we can do that. Okay. So it's the 1 volt, 1.8 volt, which goes out of the the buck converter. So it's generated around this inductor. This inductor generates by the switching, and then with the capacitors at the output, you have a stable 1.8 volts generated. Goes down here, here, all the way here, and then down to here, where we have the ferrite beads to clean up the signals and the noise it might have picked up on the way, and getting it ready for the FPGA. I can actually... no, I don't like doing it this way. I like to keep lines 45 degrees, otherwise you kind of get lost in the angles, and we can't make planes align properly. Can't I just maybe I don't think, is there a way to force planes to be 45 degrees? Okay. Great. Now we need more vias. Maybe do it like this. And like this. Okay. Yeah, so I was moving around the blue tracks here because they are gonna be in our way, and I don't like them going just below the power plane. If I can avoid that, it's better. So like this, and this one too. Good. Is there room for this one to go the same way? Great. Yes, but this isn't much better. Yeah, no problem, actually. We are just gonna do that. No, can't we? Where does this one go? Ah, yes, it's the test point. Always the test point. Yeah, I think we can have an idea of where it can fit, and maybe we can just put it right here, actually. This is large. Okay. Yeah, it's starting to be a bit crowded around here. I'm trying to see if there is an improvement I can do for that. I don't think there is, at least not now. I don't like the fact that this, yeah, but they are gonna have to do that anyway, I guess. Okay. And this needs to be connected to the capacitor right here. Right, like that. Okay. Perfect. Good, good, good. Okay, here we need ground capacitors. VS, sorry. And it's all the incorrect net. We need ground. Ah. Okay. Good. We can add one more right here. And right here for good measure. Do we need... Let's have ground vias around here too. just where we cross the layers. This one needs ground vias. Great. We need ground vias here. Oh yeah, we need to do the 3.3 volts now. It's coming out of here. Maybe this doesn't need to be right here. Okay, and now, so 3 volts rail. How are we gonna route that so that yeah, this one, we'll do that later on. Okay, let's try to do 3.3 volts, and then once we're done, maybe we'll leave it here for today. And this freezing thing is happening way too much. I don't know, I have no idea what's going on. I tried to Google it and nothing came up. So yeah, just not correctly working. Why, I don't know. So let's create a plane just below that one. .3 like this. Then we need vias to connect it, and we can do it like this. So just having a quick look at the schematic, where do we need the 3.3 and where do we need the 1.8? I do believe that there is only the 3.3 volts, yeah, here in the, for the transceiver. And this one can pull quite a few milliamps, so it needs to be done carefully too. So maybe we can try to go down this way to the transceiver, and then we can have a track go out to here. No audio. Okay. Okay. It seems my mic is not picking my voice anymore. Huh. Yeah. Okay. Is it It's better now, is it? I think. Yeah. I don't know why it does that. And it's now even, it seems that it's saturating a bit. I'll just put... Okay, like this it shouldn't be saturating anymore. It seems that there is some kind of automatic gain control which I'm not aware of. Okay, it's... yeah, I don't get it. Yeah, it's just that I have the audio control, the view meter on OBS, which was like blinking red. Or yeah, maybe I can do that, and like this should be better too. And so yeah, OBS will, I'm just gonna reduce a little bit the volume in OBS and it should be good. Sorry, yeah, the same problem happened to Steve a few weeks ago. I had the same problem come up, which is why I knew how to solve it. And yeah, he basically cranked up the volume just to compensate for my volume going down. And then when I fixed the issue, I think he even screamed, and people in his office were afraid. So okay, nice. Okay, great. We were saying 3 volt rail, 3.3 volt rail. Okay, so we are dragging that down, trying to keep 45 degrees, like this. And then create new colors. Moving it. Okay. Ah, no. Misclick. Dragging it down. Yeah, we can actually okay. Like this. Oh, this is good. No, I need to. Okay. Perfect. Okay, good. Guess we can also create new corners right here, and then drag that to here. actually, so whenever I'm moving my mouse on previously placed corners, I just press the space bar to reset the local coordinates, which are displayed on the bottom of the screen. So right here are the local coordinates which I can reset. So if I place my cursor here and press the space bar, you see that it goes to 0, and so you can make relative movements thanks to this. It's very, very useful. I use it all the time. And so you see that dx is equal to 0, so that means that I'm aligned in x with respect to the previous position, which is quite good to know when you try to keep things vertical or horizontal or 45 degrees. So again, here I align my corners, press space bar, and then we'll try to keep dx equal to dy, which will tell me that I have a 45 degrees angle. Then I can drop that down by a few fractions of millimeters, like this, and like this. Okay. And then like this. And I needed 3.3 volts right here and there. So this can be done easily. There's barely nothing which is gonna be consumed on these rails, so I can just do something like that. No, I will just maybe first select a wider track and then can keep routing it like this. Like that, basically. Oh. Okay, so that's like this, much better. Also need to tell it which net it is, otherwise it's not gonna connect to anything. 3.3. I also need ferrite bead, and I'm gonna try to keep this ferrite bead close. Actually, I can maybe move that plane, that thing. I don't like the way the ground planes are moving. It's so much better in Altium. You can drag it and it's gonna keep the angles, and here we can only move the sides, but it's gonna change the angles of the other planes. I'm just gonna run a quick search to see if I can change that behavior. Yeah, it seems that there is a way to do that, actually. So we just need to find where it is. Would this be enough? So if I do that, ah, amazing. Oh, good. That's so much better. Okay, nice. Then I can maybe drag this to right here, and have the ferrite bead be placed around here. KiCad for the win. Yeah, KiCad is very, very powerful actually. Usually I find that this kind of software, it's the same for Altium, but if you are clicking too much or something like that, then you are doing it wrong. It's rarely the program which is doing it wrong, trust me. The ferrite bead, which one was it? This one? This one? No, this one. So what is this? 10K. Oh yeah, okay, that's for this one. So I can... would there be a way for me to have two vias? I guess if I drag that down a bit and place one more. Like this. I just need that, but then I guess it's gonna remove the one on the top. Yeah, so I need to okay, and tick remove redundant tracks. Then I can do that, and yeah, okay, that's not gonna do it. Need to maybe do it like this. Okay, good. Okay. Okay, and where does this need to go? It needs to go, yeah, but okay, so this can't be here. So this, Okay, like that. It's yeah, actually maybe we can just do that and remove that. Does it help us? Yeah, we can move that down. Okay. And then I can drag that down. This one too. And then we have room to have this go right here. Like that. Okay, great. So okay, great. So that means that we have now 3.3 volts being routed properly. Yeah, those we are gonna place in the end. So 3.3 volts routed properly to the FPGA, which is great. So basically all the power tracks for the FPGA are done. Oh no, this one needs to be, yeah, okay. I think we are it's quite good now. All the grounds need to be connected, but that's okay. VCC aux, why is it telling me that I have to connect it? This is annoying. Okay. Why is this one showing as with a... This should be connected to this. Oh, this one is not connected. Yeah, I forgot about that one. Yeah. Let's do that. So that means we can drag that. Then we can have a via placed right here. Okay, we managed to place one. Great. This can get closer then, and we would need to route the track. Like so. But we want to be nice and thick. Okay, great. So this one now is connected to VCC aux. So does it complain about any track, any power pad being not connected? This one, it's complaining about that one. Where does it want it connected? That one. That one. Oh yeah, it's the pull-up for the jumper that we can use to set the programming port in either SPI master or JTAG, and which we are gonna place later on because it's not critical, and we are gonna place it wherever we have some room for it. Okay. Yeah, I've been streaming for an hour and a half now. I don't think we are gonna have the time to route the power supply here though. So we have this. Yeah, and this one needs to be routed carefully too, because we have a mix of digital and analog power signals, and so yeah, we want to avoid mixing them, and so we will have to copy to have a look at the reference design from the manufacturer to see how they manage their different power signals. But you see that, yeah, we have DE VDD, which is digital external VDD. We have that 1, 2, but I think some of those are EVDD, but because they are connected, yeah, maybe we can try to use a net tie for that. Oh. Yeah, okay, this. And so we would have, nope, not like this, like this. Does it need a footprint? Net tie. Let's see how they do it. It seems that they have a library with net ties, do they? Net tie, What does it look like? Yes, but it seems to be always on the top or bottom layer, which I'm not a big fan of. No, I don't think. Yeah, we are not gonna use that. We are not gonna clutter the schematic for that. Yeah, 15 minutes to the net. Then maybe it's a good time to to stop the stream, we've been here for a bit more than an hour and a half now. So yeah, so we did quite a few things today. Mainly the 3.3 volts to the FPGA and down to nearly the transceiver, the 1.8 volts for the FPGA, which is completed. 1 volt was done previously, we just optimized it a little bit. So this also can be moved like this, okay. So yeah, I think it will be good for today. This one is not connected to VCC aux. We can do that. Okay, so now this one is connected. Great. Well, let's save that and push it on the gate. Okay, like so. Okay, I don't know when the next stream is gonna be, but yeah, I'm gonna try to tell you as soon as I know. Maybe Monday I should be able to do a stream, I think. Monday during the day in Europe time, so yeah, let's say in the maybe it should be about in the morning for the US, and PM in the afternoon in Europe. But yeah, I'm gonna see how it goes on my side and tell you once I know. Okay, thank you everybody for being here today. It was nice discussing with you, and see you then on the next stream, I guess. So bye bye.